Okay, so this was it in terms of general overview of the app. So as I was saying, we will go through a demonstration, two demonstrations, two examples. First, we will use the built-in example mainly to demonstrate the main functionalities of the NMA. Then we will use another dataset that we will try to upload to see precisely the data uploading process. Okay, so the first data, the built-in example, come from a recently updated systematic review for chronic plaque psoriasis. The data comprehends 158 RCTs and compares 20 different drugs. There are two main outcomes that we will analyze. As I was saying, NMAstudio allows for two outcomes to be analyzed together. One is in terms of efficacy and one in terms of safety. Both outcomes are binary in this case, and we will use risk ratios. Also, the first outcome is a beneficial outcome, and you will see that this is important in the app. And the second one is a harmful outcome. So I think we can directly go and have a look at the app. I hope you can see the screen, but this is the main web page of NMAstudio. So first, the user will have to upload their own data from here, but we will skip this part and we will go back to this later. So suppose we have uploaded a data set, then the network plot will appear here on the left. And this is a interactive object. You can move it around, you can drag any different treatment if you want to reshape it, let's say. And also there are additional settings that you can use to modify and customize your plot. So for example, you can change the layout, you can go through different options and see what works best for your network. Now I will not show all of this, of course. Then there are different options for how you can save the plot in different formats. You can, for example, remove the edge sides, which, as we said, is related to how many studies are present for a specific comparison. Also, the node size, for example, you can have the number of the node size proportional to the number of participants randomized in each treatment. Also, some additional settings for the coloring of the plot, for example, by risk of bias. So in this case, we have information into our data set about the risk of bias of each study, and we will summarize it here. Or also another option is to color the network by class of treatment, if this is something that you have in your network again. So in this case, for example, we have 7 different classes. Also, another option is that the user will choose his own color, either with a name or in X format. So you can just type in, I don't know, blue or whatever other color you prefer, and change the color, and you can go back to default. And finally, again, you can change the edge color. Actually, here we want to add some more features. Some of these features already exist also in Cinema, but we plan also to add some more. You can also add the label if you want to save the network with the number of studies in each comparison appearing in the network. And then all of these different customized plots can be saved. So it will be saved as it appears in the app by clicking on this icon here, Save Graph. The default is PNG, but if you can change it to these 3 different options here. And here you can also, if you want to expand the network, to have a look at the network a bit more into details, or if you have a very large networks, sometimes it can happen that you have nodes which are a bit overlapping. So first you can manually resize it a bit using these features. And also if you use a large screen and you use this expand button, you shouldn't have problems because generally it's very spread out. Okay. So another feature in terms of network is that we can have a look at the way the network evolves over time using the slider here. So in the data tab, you will see the first time in which a trial was available up until the last time. In our data, this is a last available trial is in 2020. And so, for example, we can go back to the first time and see that in 1963, so this is quite old trial, there was only this evidence available. Then nothing was going on up until 1990, when another trial involving another treatment was available. And then so on, you can go on in time and see that at some point more treatments are added. And also you see that the data table is filtered in real time as you slide through the slider. And then up until, again, all of the evidence available in 2020. Okay, also in terms of filtering, the data can be filtered by clicking. So we said that the main feature of this app is to click, the ability to click on the different nodes or treatments. So for example, if I click on this node here, I will have the data filtered by that. I can also see it expanded and I can export it. So this is also a way to filter very easily your data and export it. I can also click on multiple nodes or edges. So if you hold Shift, as it is written here, now you don't see my keyboard, but I'm holding the key Shift, and I can click on more things like more edges or more nodes, and the data set will be filtered accordingly. Then if I click on any point in the black part of the screen close to the network, we will reset to the default option. Okay, so I think this is, if I'm not forgetting anything, pretty much everything in terms of network customization. So now we are ready to see the different key steps of the NMA that I was talking about before, starting from the first one that we said is the transitivity check. So at this point, Mark, probably it's time for our second poll. So as I was saying, transitivity refers, it's a key assumption of NMA and refers to the plausibility of using indirect evidence. So a way to graphically check whether this holds or not is to compare the distribution of your potential effect modifiers across the different comparisons. So a way to do this is to construct the distribution, so the box plots in each comparison, and see if they are similarly distributed across comparisons. So I'm seeing the results of the poll, and it seems the majority of you always check transitivity, so that's good. That's what we should always do. It's a very important step. And a way to do so here in NMAstudio is to click directly on the choose effect modifier drop box and choose your effect modifier. So if you remember the name, for example, you can type in age, which is an effect modifier which is typically checked, and NMAstudio will find the variable for you. And you can go here and you see that you will have the the distribution of the different box plots here. Also, these plots, and this is true for all of the subsequent plots, they are interactive in the sense that, for example, they're, the labels and the axes are editable, so you can customize it a little bit more. So here in this case, we probably don't need a label, but here, for example, you can say age or whatever other name you want to give. If you hover on each box plot, you will have additional information of the, for example, the quartiles and minimum and maximum and so on. And also, another feature, again, in terms of interactivity with the network, is that you might want to highlight some comparisons, for example, some that seem to deviate more or some others which are of interest. And you can do so by clicking on an edge. And now I'm just picking at random, but you see that you will have the corresponding box plots highlighted. And again, you can put your name to the plot and you can save it. And it will be saved as it appears. So here you have options for zooming in, zooming out, or just zooming in a particular area of the plot, and then clicking here, it will be downloaded. Then you repeat this procedure for all of the different effect modifiers that you want to check in your network. And once you have checked transitivity, you can go on showing the summary of the effect. So for example, forest plots, in this case, we have 3 different options. The typical NMA forest plot, so of overall network estimates, then the typical pairwise forest plots, and an option for a bidimensional forest plots, including both the NMA forest plot for the first outcome and for the second outcome, if this is given, of course. So this option is only available if you provide 2 outcomes. So here, to construct our NMA forest plot, first thing we need is to choose a reference. Again, you can choose any reference you want, clicking on the network. So for example, you click here, as it is usual, we pick placebo, and you see a plot appearing here. Importantly, also here, you will have to choose the direction, because of course the interpretation of the plot depends on whether the outcome is beneficial or not. And also you can repeat, so here hovering, you have additional information as before, and as before, you can save the plot from here. Since we have 2 outcomes in this case, you can also move to this toggle switch here and show the results for the second outcome. In this case, this is a harmful outcome, so we will also have to toggle the switch. And also automatically, once you switch to the outcome 2, the network will appear for outcome 2. Of course, not always they are the same, right? Because some treatments or some effects might be missing in one of the 2 outcomes. Then we have, as I said, the option for pairwise forest plots. So this is the standard meta-analysis forest plot. So in this case, instead of a node, you will have to pick on a comparison. For example, you can pick here, and the forest plot will appear with the summary effect and also prediction intervals. All of these annotations are also editable, because sometimes, as it happened here, for example, they are a little bit misaligned. So you can just do this and realign it, and then you can save it properly, again, clicking on here. Then the third option, the BMA, the bidimensional plot. So as I was saying, again, we need to pick a reference for our plots, and the bidimensional plot will appear. Of course, the interpretation depends on the outcomes, so whether they are beneficial or not, which region of the plot you should look at. So now probably there's no time to focus more on interpretation, but you need to look at the region of the plot which is more of interest, and also sometimes this is contains many different treatments and it's a bit messy, so you can also remove, by clicking on the legend, different treatments to have a more a neater plot, and maybe perhaps you just need to show a few of these. And again, you can choose the labels here. Then moving on, we said another part related to the summary of the effects is the league table. So here you will have all of the different pairwise comparisons between all of the different combinations of treatments. So league tables tend to be, of course, very large. And here you can scroll to see the full table. And also you can expand the table to see it a bit more clearly and export it. So a feature of this league table here is that it can be colored. So far, NMAstudio allows to color the league table by either risk of bias. So this will be the risk of bias in the direct comparisons. So what you have in your data set. And this can be a low, medium, or a high risk of bias. But also, as I was saying, can connect to cinema. to provide a coloring of the table, which refers to the overall reporting of cinema. So cinema, we said, analyzes different domains, for example, within study bias, indirectness, heterogeneity, and so on, to provide a full, a final score of what is your confidence in the evidence. And the confidence can be very low, moderate, or high. So once we read in the final report from cinema, and we will do this from here, we will see this in the second demo, you will have all of the different comparisons colored by confidence in the evidence. Also, you see that if you hover on a specific comparison, you can also have the reason for downgrading. Here we don't have it because I think it's quite a recent feature that was added in cinema. So at the time this assessment was done, it was not possible to have it, but now you also have a column in cinema which tells you why the evidence was downgraded. So if you read this in too, you will have the reason for downgrading appearing here. Then moving on again, we have the part in which we need to check the consistency. As I was saying, this is the statistical assumption, again, related to the validity of performing indirect evidence. And we do so using two typical tests, so design by treatment interaction model and the node splitting models. One is a global test that tests inconsistency throughout all the network, and the other one is a local test, which tests inconsistency in each comparison. So you will have the results here for both outcome in the case of the first table, and for first outcome or second outcome if you toggle this one for the other one. You can scroll down and see your results, and you will have your associated p-value. Every time the p-value is, let's say, suspicious, so it flags a warning of inconsistency, you will have it in red or in yellow. Again, you can filter this table just clicking on the edges to select only a few comparisons, and you can export these tables. Also, there is an option to export a full table, so not only for the direct comparisons, but for the full comparisons, also the indirect ones, as it is provided in NetMeta. Moving on again, probably a bit quicker because it's getting late. Another assessment is related to small study effects. As we said, this is typically carried out with the comparison, what is called comparison adjusted funnel plots, which tests for the presence of small studies. We can pick, again, a reference treatment and show the associated funnel plots, and we can make our judgment, again, for both outcomes. And you can choose any other treatments to be the reference, of course. Then finally, we get to the point of the ranking. So in this case, we provide two different plots, both based on the p-scores as they are calculated in NetMeta. So p-scores is the frequentist analog of the more common SUCRA that you probably all have heard of. So this assesses the average degree of certainty for a treatment to be the best compared to all of the other ones in the network. And here, the first plot we provide is a heat map. So you will have a heat map of sorted treatments from best to worst for both outcomes. Of course, again, you need to choose the direction because the ranking heavily depends on the direction of the outcome. And then a scatter plot of p-scores for both outcomes. So again, it is important not to forget the step. You choose the direction of the outcome, and you look typically in the upper right part of the plot where you will have the treatments that seem to perform best in both outcomes. Okay, so we will see some additional features once we go through the data upload, but this is pretty much all in terms of the main functionalities of NMAstudio. So going back to our second example. So I don't know if you have any, by the way, any questions so far. So if there's any question, I'm happy to take it. I know it was a lot of information to be passed all together.
Just to note, so in the chat, there is one question.
Okay.
About, is it possible to have a confidence interval for direct and indirect evidence?
Where?
Or each comparison in the nodes looking network. If you can see the chat, the last couple of
let me. Okay, so for consistency, is it possible to generate forest plot? So yeah, the typical forest plot that is, for example, that NetMeta has from the net split. So far we don't have that. We just provide the table, which basically tells you the same thing, but we didn't provide the option of the forest plot because, again, typically these are very, very long, and so in terms of putting that into that box wouldn't appear so nicely. But if it's a feature that people believe useful, we can think of it. Wouldn't be hard to add that, so we can think about it that.
Okay, thanks. So if there are any more questions, there's one. Well, it's a question about RevMan Web just popped up. Is it possible to link this to RevMan Web yet?
No, not. It's not possible. Also RevMan, I think it's more focuses more on standard meta-analysis, if I'm not wrong. So this is while NMAstudio is fully built for NMAs.
I just wonder, I think we've sort of blurred two questions together here. Just a question, a couple of from Cynthia, a couple of questions further up. You can scroll back up the chat, Sylvia, about comparing direct and indirect evidence in the node splitting model. Can you see that one?
Is it possible to have a confidence interval? Yes. So you mean, yeah, in the table rather than the p-value to add the confidence interval? Is that the question? In that case, okay. So maybe I didn't get what.
I'm not quite sure what the question is. I'm not quite understanding the question, I'm afraid.
Yeah. Okay. Yeah. Okay. Anyway, it is possible, of course, to add the confidence interval for that. Maybe I because I couldn't see the question in the chat, so maybe I missed a little bit the question. But next to the point estimate, we can add a confidence interval. We can add that.
If we could carry on, then I think, Sylvia, I think if there are any more questions in the chat,
thank you. Okay, sure. Thank you. Okay, so as I was saying, we also will go through a quick other demonstration mainly to show how you should upload your data. So in this case, we will use another data set, which compares 21 different drugs for a major depressive disorder. This is a very large data set, but we will focus on a subset, let's say, of this data set. So we will exclude placebo-controlled trials, and we will only focus on head-to-head comparisons. So we will end up with a data set of 179 RCTs comparing 19 different drugs. And in this case, we will only analyze one outcome to see the differences between what I've shown now, which is with two outcomes. The outcome is an efficacy outcome again, and is a binary outcome, and we will analyze in terms of odds ratios. So before looking at the data upload, what you need in terms of files is just your CSV. For the moment, only CSV files are possible. A CSV file containing the main data set. And then optionally a CSV file containing the cinema report that we were talking about before, but this is optional. So if you don't have it or don't want it, you don't upload it, and you can just not see the table, the league table color by that, but that is optional. Then in the data selection process, things that you will need to choose are the data formats. So whether it's long, so when each study contributes a row of the data set, wide, so each treatment in the long one contributes a row of the data set, the wide format, so each comparison contributes a row, or also the wide inverse variance version. Then you will have to choose whether the outcome is continuous or binary, and your effect size, whether odds ratio or risk ratios for binary outcomes, or mean differences or standardized mean differences for continuous outcomes. So in our case, we will have a data set in a long format, which is, as we said, binary, and we will analyze odds ratios. So just to make it a bit clearer, this is, for example, these are the first lines of our data set. And the column that we will need and that we will NMAstudio will need are the following. So, of course, the study ID, then the column with your treatment. In this case, we have a binary outcome, so the number of events and the sample size. And then also we will need the year of publication, because we want to show the evolution of the network, and the column referring to the risk of bias for the additional coloring. In this case, this is the only column that needs a specific format, a specific encoding. So it will have to be saved in your data. With the name can be any, but the encoding of the bias should be either saved as low, medium, high, LMH, or 1, 2, 3. And then also, as I was saying, you can upload the cinema report, but this is optional. The important thing is that you leave it as it is saved from cinema. So from cinema, you will get a report which has for each specific comparison a column which is called confidence rating, which provides the overall confidence, as we said, high, moderate, low, or very low. And then you will also have additional columns referred to the domain on which this confidence rating was built. But these two are the only columns that we need. Okay, so again, we can go back to NMAstudio and okay, so let's say we are again at the main page and we want to upload our data. So we go through the parts that I was skipping before into upload your data. You select a file. You select your file. You go to your folder. In this case, our file is here. Then you will have to choose, as we were saying, the format. Of course, there will be documentation. There is documentation available, so we always suggest the user to first go through our tutorial for all the details about the uploading process. Anyway, here, a long format and binary outcome. We don't have a second outcome. So far, we don't do anything here. Otherwise, we would click also on the second one. We choose odds ratios. Then here, if you remember, I was showing the column names. So we need to pick the correct column name from our data. The treatment was called drug. Then we have the risk of bias. And if you start typing in, because you remember the name of the column, NMAstudio will find it for you. We have the number of events, which were the responders, and the total sample size. Only once all of these are uploaded, this are filled, this button upload will be available. Otherwise, is deactivated to avoid confusion. So we click on update, on upload, and we will go through the process. So here in NMAstudio, the analysis is linking with our build. So this is the step where all of the different analyses that we need are being calculated. This is typically quite fast. I don't know now, maybe it will take some more time. So you will see if each analysis runs successfully or not. If not, you will have an error, and which will direct you to why the error is appearing. Also, we have some data checks. These are just warnings, but it shows you that some of your variables, probably ones that are not needed and not used, are a mix of numerical and string values, which is something we always want to avoid, the presence of missing values and so on. I want to add more in here. So far, we just have a few warnings. So we go on and we wait for all the analysis to be completed. And so just a few seconds. And again, once everything runs successfully, we can submit our analysis. And the new forest plot, the new network plot will appear here with the new data table and everything. So again, you can do the same that we did before. I'm not gonna go through it. So different settings for the network. Again, you will need, and it's important to check transitivity. And then I will just show you some of the differences between what we have seen already. So for example, in terms of NMA forest plot, we don't have placebo anymore. As I said, here we only want to compare active drugs. So it's typically can be more difficult to go through the different, to choose a reference. And here NMAstudio provides a very easy way to change the reference and look at how the plot appears in real time. Again, and of course, this will not be possible because we don't have a second outcome. Same thing for the pairwise plot and also for the bidimensional plot. You see that if you try to compute it, it's not possible because, of course, we haven't uploaded the second outcome. Then again, some differences when you only have one outcome in terms of league tables. In this case, what I maybe forgot to say before is that the lower part of the triangle contains the results for the first outcome, while the upper part for the second outcome. In this case, we don't have a second outcome. So as it is from NetMeta, the second outcome, the upper part triangle will contain the direct evidence only. So it's empty, of course, when there's no direct evidence. Again, you can color by risk of bias, but also you can want to upload your cinema file. So let's try to do that. You will go into your folder, of course, where you have your cinema report. In this case, it's this one for us. And then it will say loaded. So now it's loaded and you can toggle this again. And here the cinema coloring will appear, of course, only into the lower triangle because we only have one outcome. You can look at the table here. And also if you export it, it will be exported as an Excel file maintaining the colors and the formatting. Also, what's important to see, for example, is that the league tables, as I was saying before, tend to be very large. But here you can filter the table. For example, by clicking on multiple treatments, you can have a filtering. And the order in which the columns appears are maintained from the order of your click. So that's another useful feature. And again, you can save the filter table here. Then just very briefly, same as before, just for the ranking, for example, you don't have the possibility to do this plot here, but you can easily see your P-scores heat map. And also what's important is that you can always use the network here to assist in the interpretation of the findings. For example, by looking, I don't know, maybe at the risk of bias and everything, you can see that the best treatment appears to be vortioxetine, but also what's important is to see at what treatment it is. So for example, you can highlight it here and you can see that actually it's a treatment that has only been compared in one trial, and also the number of participants is quite small if you look at the size of the network of the node. And also you can always use the league table to go into this part here where the vortioxetine is and look at what's the uncertainty in the evidence, which is also always important. So we have seen how to use the plot to also aid in the interpretation of our results.